Or is it too blurry? Okay. All right, good. Okay, so there's a couple of different approaches to this. I think the easiest one, well, first of all, domain. So this type of function is called a rational function because it's a ratio, it's a fraction. And the big problem with the domain of a rational function that you have to look out for is that the denominator is not allowed to equal what? Can you tell me in the chat, what's the denominator not allowed to equal? Good, exactly. It's not allowed to equal 0. So to find the domain is just a matter of setting the denominator equal to 0 to find any restricted values. So that would mean that 2 is equal to t. This is what it's not allowed to equal, so we'd have to leave 2 out of the domain. Now I don't recall, but perhaps those of you who have been working in my math lab can remind me. For this textbook, are they asking you for the domain in interval notation or set builder notation? Does anybody know? Interval notation or set builder notation? Interval? Okay, so when you have to write the domain then in interval notation, think of it as the rational function has a domain that includes all real numbers except whatever restricted value we just found. So if this is 2, on the real number line, we're leaving out 2. So the domain is going to include everything from negative infinity to 2 together with 2 to infinity, not including the 2, so that's why I have parentheses and not brackets there. So this would be your domain in interval notation. All right, now to find the range, we are going to do one of a couple of things. One, you could think of this, if you're familiar with the reciprocal function, f of x equals 1 over x, you could think of this as transformations of that function. That's one way, and you could think about what the range would be. Another way that you may be familiar with in pre-calculus is finding the horizontal asymptote. The denominator has a polynomial that has a higher degree than the numerator, so therefore the horizontal asymptote will always be 0. But there's another way that's more algebraic, and that is the reason we were able to find the domain by determining what the denominator here would be is because we were basically, remember, f of t is your y value. Your y value was undefined whenever that denominator was equal to 0. So let's think of the range as figuring out for what y value would the x's, or the t's in this case, be undefined. So what I'm going to do is I'm going to take the function, write it as y equals 5 over 2 minus t, and I'm going to solve for t. So that way I'll know what values I can't use for y. So to solve for t, I would multiply both sides by 2 minus t. And this would give me 2y minus yt, or ty, it doesn't matter, equals, the denominator cancels out and we have 5. Just to get t by itself, I'm going to subtract 2y over to the other side, so we get negative y times t equals 5 minus 2y. And then we're going to divide both sides by negative y. So that would mean that t is equal to 5 minus 2y over negative y. Or, if you prefer, we can divide the negative through and get positive 2y minus 5 over y. All right, so based on this then, the only value that would cause a problem for t, that would make t undefined, remember t is your x value, so it's your domain value, The only thing that would cause that to be undefined is if in the range we included a y value of 0. So y is not allowed to be 0. So your range, again, we're going to leave out 0. So it's going to be negative infinity to 0, union 0 to infinity. Okay, so whenever you have a rational function that's fairly simple like that, you can rearrange it, solve for the x, or in this case the t, and then use the same approach for the domain, for the range as you did for the domain. All right, so that was a question somebody asked me in the live chat. If you have any other questions, you can let me know right now. Or otherwise, I'm just going to pull up a couple more examples from my math lab. In which section did you have a question about an equilateral triangle, Elaine? Do you remember which section of the book it was in? 1-1, 1-2, or 1-3? Most likely 1-1 or 1-2. Question 10 in 1-1 in chapter 1, section 1. Let's see. Okay, so it says express the area and perimeter of an equilateral triangle as a function of the triangle's side length x. Oh yeah, this is a good question because later on we're going to have to be able to write functions for certain quantities in order to maximize or minimize them. So this is a good good concept to get comfortable with. Let me see. Hold on, I'm just trying to get a picture of this question here. Okay. Okay, so whenever you're given a question that has anything to do with geometric shape, just draw a picture, no matter if it seems simple or not. Doesn't have to be accurate, but we have a triangle. They're telling us it's equilateral. So that means what about the sides? What does it mean to have an equilateral triangle? Very good, Maya. They all have the same length, all the sides. So I'm just going to label them all x. All right, now when we talk about perimeter, we're just talking about the sum of all the side lengths, right? So the perimeter is just x plus x plus x, so that one's not too bad. So we could call it P of x equals 3x, and that's our perimeter. And the area is a little bit harder, right? So how do we find the area of a triangle? Well, the area of a triangle is going to be 1/2 the base times the height. So we can use any one of these sides as the base. So I'll use the one that I've already drawn on the bottom. And we need to figure out the height here. Okay, so one convenient fact to know is that if this is a equilateral triangle, then it also happens to be a isosceles triangle. And whenever you have an isosceles triangle, if you drop a perpendicular from the top between the two equal sides to the bottom, you split the base in half. So this part right here is x over 2, and this part right here is x over 2. All right, so that means that we now have each half is a right triangle, and that means that we can figure out the height h here for that right triangle using the Pythagorean theorem, right? A squared plus b squared equals c squared. Okay, so let's go ahead and let's say that A is the side x over 2, and B is the side h, which we don't know, but I'm going to call it h, the height. That's going to be equal to the hypotenuse squared, x squared. So I'm doing this just so I can figure out the height written in terms of x's, okay? Because remember our goal here, our goal is to write the area as a function of x. So we need somehow to write this expression 1/2 base times height with all x's. And I have the base is x, but I don't know the height. So that's why I split it up and I'm using the Pythagorean theorem. Okay, so now that would mean that x squared over 4 plus h squared would be equal to x squared. I can subtract x squared over 4 over to the other side, so we have h squared equals, and then we have x squared minus x squared over 4. Which, by the way, getting a common denominator here, you can think of this as 4x squared over 4, right? So we have that h squared is equal to 4x squared minus x squared is 3x squared over 4. And then now we need to get just h, but we have h squared, so we're going to use the square root property, which is like sometimes people refer to it as taking the square root of both sides. I prefer to call it the square root property because what it says is if h squared is equal to 3x squared over 4, then h itself must be plus or minus the square root of 3x squared over 4. Now, of course, since we're talking about a height, we're only going to use the positive version, so it's going to be the positive square root of 3x squared over 4. And we should simplify that a bit. So this is going to be x times the square root of 3 over 2 if I take the square root of each part of that quotient and product. So this is our h, this is our height. X times the square root of 3 over 2, or root 3 over 2 times x. So now I can write my area as a function of just the dimension x. I have 1/2 times the base of the whole equilateral triangle, which was x, times the height of the equilateral triangle, which is x square root of 3 over 2. So multiplying that together, you could write it as root 3 over 4 times x squared. So that would be a function describing the area of any equilateral triangle. Okay, and again, one reason why this is important to us in calculus is because we're going to be looking for maximizing and minimizing quantities like areas, and we're going to use functions to do it. All right, so that was a good question. Well, I should write it like this. A of x equals, okay. right, were there any other questions that you guys had from the section 1.1, 1.2, or 1.3 homework? By the way, I'm going to post a link to this file in our classroom, so you'll be able to access it. Anytime somebody sends me an Ask My Instructor question from our book, I add it to this file. There's a couple from last semester in here, not a lot yet. Hopefully we'll fix that this semester. Get a lot more in here. Okay, if there aren't any questions, I'm going to start pulling some up. Oh, Priya has a question, or Priya, sorry if I'm pronouncing your name wrong. Question from the section 1.2 homework. Okay, let's look at that. Okay, section 1.2, question number 10. Oh, okay, composition of functions. All right. So let me grab a screenshot of this. Oops. Okay. Now that's funny. I have this one in here already, but let's walk through it. Okay. So obviously you're not the first person to have this question. Let's see. Okay, so yeah, one approach that we can try is, well, let me show you. Okay, so before we actually work this problem, I want to make sure everybody's on the same page about what composition of functions is. So, for example, let me go down, let's see. Go off to the side here. F composed with g of x is actually saying take f and plug g of x into it. So for example, if your f of x were 1 over x and your g of x were, say, the square root of x, then we would take f and we would plug in the square root of x. And that would mean, what does f do to anything you plug into it? It takes a reciprocal of it. So that would be 1 over the square root of x. Now this gives people fits because of the different x's that are there. But just remember, think of the x not as being the same x as in the other function, but as a placeholder or an empty box that needs to be filled. And in this case, we're putting the square root of x into the box. Okay, all right, so notice how we took two completely different functions and we combined them by using composition. But what they're asking us here is, to find what g of x we would plug into this f of x in order to end up with a 2x in the end. All right, so what I'm going to do is I'm going to write down an f composed with g of x and immediately change it to that other notation, f of g of x. All right, so I don't know what g of x is, but I do know what happens when I plug g of x into f. What f does to anything we plug into it is it takes it and divides it by itself minus 5, right? So we're having to put now g of x into the function f. So we're going to have g of x over g of x minus 5, whatever that g of x is. And we want that to turn out to be equal to 2x. So we're going to treat this like a formula. It's like we're solving a formula for a particular variable. If you're not comfortable working with g of x notation, you can always switch that to, you know, a y or something. But I think it's good if you get comfortable working with this notation. So I'm just going to leave it as g of x. So I'm going to take the equation g of x over, oops, I wanted that to be black, over g of x minus 5 equals 2x, and I'm going to solve for g of x. All right, so what do you do to solve a formula for an unknown, for one of the variables in the formula? Well, the basic idea is to get any terms that have the variable you're looking for on one side and any terms that don't on the other. But we can't do that yet because right now we have a fraction, a rational equation. So we first have to clear the denominator. So I'm going to multiply both sides by g of x minus 5 to clear that denominator. And when you do that, this is going to cancel out and leave a 1. And we're just going to have g of x equals 2x times g of x minus 5. Okay, now I'm going to distribute through the parentheses. So I have g of x equals 2x times g of x minus 2x times 5 is 10x. Oh, excuse me, someone's knocking on my door. Hold on. Sorry about that. Okay, so now we're going to go with the old rule of get the variable you're looking for, the terms that have the variable you're looking for on one side, everything else to the other. So what I mean by that is this term has a g of x, this term has a g of x, and that term doesn't. So I'm going to go ahead and subtract 2x g of x from both sides. So we're going to have g of x minus 2x g of x equals negative 10x. And then once you get to this point where the terms that have the variable you're looking for are on one side, the trick is to factor it out. So here we have a g of x, here we have a g of x. We're going to factor that out. And what's left behind in the first term is just a 1. And what's left behind in the second term is 2x. And then after that, the last step is always just to divide by whatever is being multiplied by the variable you're looking for. We're looking for g of x. So we're going to divide by 1 minus 2x. Okay, so this reduces and we have g of x equals negative 10x over 1 minus 2x, which is a perfectly valid answer, but a lot of times if we can reduce the number of negatives in an expression, we do. So notice that this negative could be distributed to the denominator and we'd have positive 10x over 2x minus 1. So you might see it written in this way as well. Right, now let's say that you're not sure about your algebra or something like that. How could you check your answer? Can you tell me in the live chat how you could check this answer? Remember, what we were looking for was a function. We were given the function f, and we were looking for a function g, so that the composition f composed with g of x would turn out to be 2x, right? So if we wanted, yes, that's right. If we wanted to, we could just plug g into f and see if we can simplify that down to be 2x. So is that something you would like to see, or would you rather move on to something else? Is there anybody who'd like to see it plugged in? Okay, I don't think we're getting any votes for plugging it in, so that's the solution. And are there any other questions from any of the homework from 1-1, 1-2, or 1-3? Okay, if there aren't any questions from anybody, I'm going to pick one, since we've already worked one from each of sections 1-1 and 1-2. I'm going to pick one from section 1-3, trigonometry. Oh, you have a question, Elaine? (1.1) question 15. Okay. Okay, so this question is about piecewise defined functions. All right, let's start with part A here. I think that's 1.1.29, was it? Yeah. Okay, for this item, so notice that this graph is two line segments put together, right? So I'm going to highlight the first one in yellow. Here we have a line segment, and then we have a different line segment on the right here. So each one of these is going to have to be written as a different equation. That's what a piecewise defined function is. It's like the function can't be written as a single equation. You have to break it up into different rules. In this case, the rules are going to depend on if we're on the interval from 0 to 6 on the right, or if we're on the interval from 6 to 12, I'm sorry, on the left, excuse me, 0 to 6 on the left, or if we're on the interval from 6 to 12 on the right. So what's going to happen is we're going to end up with some function, and it's going to be equal to one of two rules. The yellow rule will happen when x is between 0 and 6. And the blue rule is going to happen when x is between 6 and 12. Okay, now notice that at 0 we do actually have a function value. There's a closed dot, not an open dot. So x is going to be allowed to equal 0, so I have to put in or equal to here. And you can either define x to be, you can either let the 6x value be attached to the yellow rule or the blue rule, because it looks like they're going to be the same anyway. So I'm just going to let it be attached to the yellow rule. So I'm going to say, I'm going to tell this rule will define what we get when x is 6. The next thing we have to do is actually figure out what the rules are. Since both of these are lines, we're looking for the equation of a line. So the yellow rule is going to go through the points 0, 0, and 6, 6. Okay, and what do you need in order to determine the equation of a line? You need a point and a slope, right? It's great if the point happens to be the y-intercept, because then we can use the formula y equals mx plus b, and we just figure out the slope, and we have the y-intercept, and we plug them in. Well, in this case, we do. We have the y-intercept, which is 0, 0. So we know that b is equal to 0. And we can easily figure out the slope m by using y2 minus y1 over x2 minus x1, which is going to give you 6 minus 0 is 6 over 6 minus 0 is 6, which is going to give you a slope of 1. So we have y is equal to 1x, or just x, plus 0. So this is actually a piece of the line y equals x, the piece restricted to the interval from 0 to 6. Okay, any questions so far on that part? Or anything you want me to repeat, just type it into the chat bar and I'll be sure to do that. All right, so if that's the equation of this line, then that means that our function f of x, remember y is f of x, so our function f of x is equal to x on that interval, which makes sense, right? Because if x is 0, we plug in and we get 0 for y. If x is 6, we get 6 for y. All right, but now we need to figure out the blue rule. And to figure out the blue rule, we need to consider that we have the point 6, 6 and the point 12, 0. And we need to find an equation of that line. Now in this case, we do not have the y-intercept. We have an x-intercept, but that doesn't really help. So, I mean, it helps, but it's not as simple as knowing immediately what b is. So what we're going to do is we're going to first find the slope. So y2 minus y1 would be 0 minus 6 over x2 minus x1 would be 12 minus 6. That's going to be negative 6 over positive 6 or negative 1. So we know we have a slope of negative 1. And now you have a couple of options how you go about finding the equation of the line. I personally prefer to still use the equation y equals mx plus b and just plug in what I know. I know, for example, that m is negative 1, and I know x and y coordinates. You can use either pair here. I'm going to use 6, 6. So what I mean is when y is 6, m is negative 1, x is 6, and we just don't know what b is. So these are 6's and that's a b. Okay, so 6 equals negative 6 plus b. And so we're going to add 6 over and we get b is equal to 12. So we now know that the slope is negative 1 and the y-intercept is 12. So we have y equals negative x plus 12, negative 1x plus 12, but we don't have to write the 1. All right, so our function f is going to be equal to negative x plus 12 on that interval. So going back up here, negative x plus 12. So this would be a way of writing the equation for, or the rule for this function. Okay, any questions about any part of that? All right, there was a part B as well, so go ahead and type your question in if you have one. Meanwhile, I'm going to look up part B here. Oops, no, oh, it's the same one, that's right. Okay, so now let's write a piecewise defined function that would give us this graph. We have a scale, it looks like, of 1 here, 1, 2, 3, 4, 5, negative 1, negative 2, etc. 1, 2, 3. Okay, so it looks like our function, again, let's highlight the two different pieces. So we have one piece that goes from -1 to 1, and then we have another piece that goes from 1 to 3. Now, in this case, it's a little easier actually because these are horizontal line segments. So, for example, here we know that this one in blue is a piece of the line y equals 1, because this horizontal line that would go all the way through 1 would have every y value would be 1. And in yellow down there, that one is a piece of what line? Can you tell me in the live chat? Are you guys still with me? Very good. Y equals 0. Okay, so what piece is all we have to figure out? We know our function f of x is going to equal 1 on one interval and it's going to equal 0 on another. Doesn't matter what order, although usually we go left to right. So I guess I'll put 0 and then 1. So the piece on the left, the yellow piece, we need to figure out what interval that is, and the blue piece, we need to figure out what interval that is. All right, so for the yellow piece, we're looking at x values going from -1 to 1. So you know you're going to write -1 is less than x is less than 1. But you have to think about the endpoints. So are we going to include the endpoints or not? So in this graph, notice we have closed dots at both ends of the yellow segment. So that means that we are including -1 and 1. So we need an or equal to on each of those. All right, now the blue line segment is defined for x values between 1 and 3. All right, now is x allowed to equal 1 on the blue line segment? No, that's an open dot. In fact, we couldn't possibly have x allowed to be equal to 1 on that segment, because then we'd have 2 points, one right above the other, and this would not be a function, right? We'd have 2 outputs for 1 input. So definitely no equal to on the 1 there. But we do have a closed dot at the 3, so we are going to have an equal to on that one. So f of x equals 0 when x is between -1 and 1 inclusive, and